From HanselMinutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 311, recorded live Thursday, March 22nd, 2012. Support for Hansel Minutes is provided by Telerik, offering the best in developer tools and support. Online at www.telerik.com. In this episode, Scott talks with Richard Minerich and Phillip Trelford about using F# in .NET projects.
Hi, this is Scott Hanselman. This is another episode of Hansel Minutes. Today, we've got two people on the phone. We've got Richard Minerich, who's calling in from New York, and we've got Phillip Trelford calling in from London. How's it going, gentlemen?
Great. How are you?
I'm a little bit low today. I've lost an octave, I think, but I will survive. I've got the cold everyone's got right now. So you guys are both user group leads of F# user groups, and you're doing F# in your everyday life. You're thinking about F#. I know, Richard, you're an MVP, and Phillip, you do games, and you do a lot of business applications, and you do a lot of open source. I still haven't quite gotten my brain around why I should care about F#. I mean, Richard, is this just a researcher's language? I mean, how did F# come up so fast? And really, as a C# developer, why should I care?
Well, there's a lot of good reasons to use F#, but I would say the best reason of all is maintenance. Because when you write your code with F#, it really becomes a much it provides a much safer environment in code because of the immutability and the way the types fit together. This really means that one developer, right? I work primarily by myself, and I can build like a really big app really fast because it's so terse. And then the maintenance is very low because changes don't necessarily ripple through the system the same way they do in an object-oriented language, and also the type system is a form of protection against bugs.
Phillip, Richard said immutability, and he said it like it was a very obvious thing. What does that mean for people who may not necessarily be familiar of that why that is such a fundamental aspect of F# and why it's such a useful thing?
Well, it means that instead of changing something directly, like going and injecting something into the first element of an array, you might return something new. Now that sounds like it might be really inefficient, but it's not, because there's fancy data structures you don't need to worry about underneath the hood that handle most of that. It's really quite nice.
So Phillip in London, so he's saying that rather than changing things and changing the state of something, you're always returning something new?
Yeah, in F#, it's not a purely functional language, so you can either go immutable, so not change, create a new instance, or you can mutate if performance is what you're after. More often than not, sort of by the 80-20 rule, you're not always in a high performance area, and you're looking for correctness. That said, immutable objects on a garbage collect environment aren't actually that expensive. The garbage collector likes creating and collecting lots of small objects. So you get that correctness and with very little cost.
Phillip, doesn't that mean that I have to fundamentally change the way I think about solving a problem? That if I try to go and simply translate how I write C# into writing F#, that I won't really be writing idiomatic F#. I won't be writing F# in the way that it wants to be written.
Absolutely. I think you're right there. It is a change of the way you're thinking. So you can start out with an imperative view with for loops mutation in F#, but it's more naturally a functional language. The types are immutable by default. So if you want to mark something as being changeable, you actually say it's mutable. So you want to move towards a more transformational mindset. So instead of thinking about mutating and doing things as a recipe, you think, I want to go from A to B, and how do I transform from those two things? Now, that sounds that is quite a bit of a mind set shift. But in this world where we're trying to deal with concurrency and multiple processes, if we look at problems from a transformational point of view, where we're not mutating small bits of state, then we have that safety, and we can actually run our programs across multi-core in parallel or concurrently, and things don't go wrong. So that's got to be actually that initial thought will cost you a lot less thought and a lot less problems in the multi-core environment.
I just wanted to mention that when I learned F#, I had been a C# programmer for years, and I had never done a functional programming language outside of college before, so I didn't really know what I was doing. But F# really can be treated sort of like a more Python-y version of C#, and then you can build your way up in learning the constructs over time. And F# has this sort of feature that's it's hard to describe, but it pushes you in the direction of immutability. Immutability is just so much more convenient that in using it over a period of time, your code will get more and more immutable, and you'll learn more and more about where you need to do the mutation in order to be safe and or in a way that's safe and in order to be like performant. So it's not like you have to learn all these features out of the gate and be able to write this fancy code. It really can just be like a terser version of C# at first.
So Philip said something really interesting there, that if I start doing my functions as kind of mathematical functions, in that something comes in, is transformed, and then comes out changed, and I chain them together like that, that allows me to do things over multiple processors. What is it about F# that makes that so friendly? That idea of immutability, enabling things over multiple processors. Does that mean that changing state itself makes an application not easy to scale across more than one processor?
Mutating state doesn't necessarily stop you, but it's adding an extra level of complexity. As soon as you do that, you find yourself potentially adding a lock or some sort of threading primitive to protect changes happening there. Now, if you're creating new objects each time, you just don't have to worry about that. Now, that said, the classic example of from a performance level is a dictionary. With a dictionary, the performance is just ridiculously higher on a mutable dictionary, the standard .NET one, compared to creating a tree each time. So there are points where you should be choosing mutable data structures. And with anything, when you're doing performance critical code, you should be guided by timings rather than sort of pure conjecture and order notation. You need some real values to know that.
So what you're saying is that there's nothing in F# that makes me like automatically get magical powers for free, or at least not magical multiprocessor powers. But some of the powers that I might get, like Richard said, they're much easier to maintain and manage because things are plugged in. There's a lot less things changing without me explicitly knowing about it. I mean, a lot of the kind of the bugs, or as my friend likes to say, Heisenbugs that we bump into in C# are something changed and I don't know why. And then we end up stepping through and wondering how that this static, variable, or this thing I wasn't thinking about, or this property switched values in the middle of my work. Do those kinds of bugs go away in F#, Philip?
Yeah, absolutely. So, this has been reported quite widely in the F# community, the idea the language kind of guides you. By default, it's immutable, so by default, you're guided into not getting so many concurrency issues. With the immutability, we've also got the async workflows feature, which we'll be seeing in C#5 when that comes along. It's basically has some of the features of F# there. So we've got a great way of describing asynchronous flows, asynchronous work, and we've been using async and immutable objects on the projects I've been on for the last few years, and we've had very few concurrency issues. Mostly we just press F5 and it works, which is the happy place, really. Just as an aside, we're using a mixture of C# and F#. So typically we'll use C# for the UI elements because we've got the great tooling around the XAML code behind. And when we want to do something that's asynchronous and concurrent or some business transformation, then we'll use F#.
See, that gets us into a really interesting place that I wanted to talk about, and maybe Richard, you could say something about this. How do I know when a problem is such a classic F# problem? Because I think there's a lot of C# and VB developers that are listening, and they'd like to answer the question, I've got a problem, and I'm not sure if this is something that I could do in 10 lines of F# as opposed to 1,000 lines of C#. And when I go and do it, if I do use F#, is it okay to have a hybrid like that? Is it okay to have an application that's part one language and part another?
Oh, well, first off, I certainly, like almost every F# programmer that's using it in production uses it in corroboration with C#. It's just because C# has amazing UI tooling. It's like better than anything out there, pretty much. It's awesome. And then you can just sort of integrate seamlessly with F#. Now, it's also really good at as Phil said, business logic, parallel, asynchronous, any kind of complicated algorithm, or even like if you have a pseudocode for an algorithm from a book or something and you want to turn it into regular code, it actually ends up looking a lot more like the book in F# most of the time. So there's a lot of things about F#. Usually whenever the code is complicated and can go wrong badly, that's when you want to reach for F# because it offers so many protections. That's really what's great about it is, there's this sort of anecdote by the guy who makes GPU.net who said, the thing with F# is once you make a part of your code base, you rarely ever have to go back and change it because it's so composable and also so, there's not a lot of interacting pieces. You just paste them together in a way you can't do without writing actual complicated code in C#. So it really is it's great for solving hard problems.
It's so hard to talk about, quote unquote, foreign languages on a podcast when you can't really show someone that. But I keep hearing more and more that if you think that you could potentially get in trouble, and you're going to be writing something that's very computationally intensive, very mathematically focused, very, very functional, financial things, transformations of matrices and things, that you really look at F# because there's so many things that will keep you from shooting yourself in the foot. Philip, do you have any particular ideas of a classic problem that you just couldn't think of using anything but F# for?
I think, everything's possible in assembler. And really what it comes down to is time, right? So one of the things, I've come from a C# background. Before that, I did C++. And actually before that, I wrote video games in assembler. The thing for me going from C++ to C# was a huge gain in productivity. And again, with going from C# to F#, there are just the classes of problems that I can do perhaps in a few hours that might take me a day in C#. And I might, this makes the difference between getting done or not done or being viable within the time frame that I have. So, one of my favorite examples is, let's say, domain modeling. So we have, say, I want to describe the retail domain. I have an example of this that I do at talks, and we're able to create that domain in about 10 lines of code using the F# type system. So in effect, you can model your domain in a page, and you can actually see the problems, solve them quickly, and move on to new and more interesting problems. I think that's one of the key elements for me. So the similar class hierarchy in C# would be spread across 8 or 9 files, and that's introducing quite a lot of accidental complexity.
Okay, Philip. So let's dig into that a little bit. I think we're hearing that F# is amazing, and we're hearing that there are certain things you could do. And you just brought up the issue of like creating a class hierarchy where in F# it could be very terse. If I were writing something like that in C#, where is all of the verbosity? Where is all of the mess? Is it curly braces? Is it unnecessary keywords? What is it that is taking up too much room, too much intellectual noise?
Yeah, I mean, C# is a massive improvement over C++ and header files, but there's still a lot of duplication. So I have like a comedy phrase I call the local government pattern, where you're doing things in triplicate to get things done. So let's say we have a person class, and on that class we have a name and an age. We would potentially describe that 3 times over. We'll have some sort of private property, or private field perhaps, or we'll have a get a set property. We'll describe it again and name the age in the constructor, and then as the parameters to the constructor. And then finally, in that constructor, we'll then say name equals name and age equals age. So we've filled out in a form in triplicate, in effect. So with F#, we can describe that with a record type, and we say a person has a name and an age, and that's it. It's a single line.
Do you think, maybe Richard, do you think that the kind of thing that Philip's describing is an opportunity for C# to take things like that from F#? And why does F#, is it simply better designed, or is it because it came afterwards that this is like this?
It's more about the family heritage and about being able. You just can't take stuff out of F# and throw it into C# easily, because F# comes from a different lineage of languages. They've split off a long time ago. I know this is sort of like sounds like evolution or something, but it really ends up being that way. So there's certain ideas that can be sort of plucked out, but there's features in F# like discriminated unions are one of the best examples of one of the most amazing things in F#. They allow you to have multiple return types from any function, multiple input types for any variable, and describe trees and all kinds of cool data structures in tiny amount of code. Any place you find yourself using inheritance hierarchies, it can pretty much drop in. And this feature, there's just no way for it to work effectively without a lot of enhancements to C#. So, some things will make it over, and some of the ideas already have, but they tend to be more of like we can add this functionality of the compiler in terms of like the async feature. Like we really need to solve this async problem, and F# does it really well. Let's do something like that, and less like this language feature about how we treat data. Those don't tend to make it over because it's hard. It's a lot harder.
Philip, you had a really good example of something that I don't think I could do in C# when you were talking about, I think it was you on your blog about the game of life, doing it in F#. Could you say something about the game of life and why doing it in F# was so terse?
Sure, yeah. Game of Life, Conway's Game of Life is a great way to learn a new language. You see a lot of people at coding dojos trying doing the problem in a new way, pairing up with somebody. So I've gone a little bit further with that and pushed that into a tweet, into 137 characters. And I've actually done a bunch of different ways, but some of the features that are unique to F# here are particularly pattern matching. The other one is literals, but pattern matching is hugely powerful.
But if we back up for just a moment to make sure that not everyone's familiar with the game, but the idea is that there's a grid of cells, right? And they're either on or off. They're either alive or dead. and then there's some transitions based on whether or not you have a neighbor. So it's fairly straightforward. Like, it's very simple in that if you read the rules, I think there's about 4 rules, and then there's an initial pattern, and then you simply let the game run, and the grid changes. And the grid could be expressed as ones and zeros or dots, or, and visually it doesn't really matter, but it's a grid. You set an initial state, you follow some rules, and you say go. And it can be explained to someone just about that quickly. I think there's 4 rules. Is that correct?
Yeah, pretty much. Yeah. So in effect, you're updating the life of a grid of noughts and ones, and you update that life by looking at all of the noughts and ones around a particular cell, counting up the numbers, and then we apply some rules to that. And we say, if the count is 3, regardless of what the current value is, it becomes 1. If the value around the cell is 2, we take the number that pre-existed. So if there was life before, there's still life. If there's no life, there's no life again. And the other rule is anything else means no life. And actually, those, in effect, 3 simple rules can make life appear to happen in front of you. So it's a beautiful problem. So the wonderful thing about pattern matching is it's kind of like a switch statement on steroids. So we would have switch case in C#, and we'd be able to say, in the case that we have the value 3 or 2, but in F# we can say we can match against 2 things at once, like a table. So we can say if it's anything and the count is 3, then there's life. If there's a number and the count is 2, then it goes to that number. And if there's anything else, we go to 0. So looking at it now, so that we can explain the main rules in that pattern match in about 15 characters, which is ridiculously terse, but at the same time, beautifully readable, because we're actually declaring the algorithm. And, you look at it, you go, that's what it does. There's no accidental complexity again.
See, if I'm trying to mentally write this, and I'm seeing a lot of if statements, and already my C# program is going to be very, very long. What is it about F# that makes it so crisp? Is it because there's just built-in functions? The notion of matching and mapping is fundamental to the language?
Well, pattern matching is a huge win, and it's one of those features that you see in most in the functional programming languages, and much more rarely in the sort of C syntax, the imperative style languages. There's some other things in this particular snippet. The list syntax in F#, and again in most functional languages, is you open a square bracket and then you just write the values with a separator. So you don't have to say new int square bracket, open a curly brace, and write the values out. You literally just get there, write the list as you would expect to see it if you're reading it in a book or something. And then F#'s type inference says, I see numbers there, so that must be a list of numbers, and you haven't had to declare the type.
So that saves you time and space as well.
It does, and it lets you just focus on the problem that you're trying to solve, and again removes that accidental complexity from you. One of the beautiful things about type inference is the sort of automatic refactoring that you can get with it. So instead of having lots of code with declaring types, and you want to refactor, you've got to go in and edit the types or use some sort of tool like ReSharper. With F#, you just change the root type in one place, and it infers the type all the way through your program for you. So that refactor step's not even required. It's beautiful, really. Mm.
Richard, both of you guys work with user groups in the U.S. and in the U.K. Are these well attended? Are there a lot of people doing F# and going to users groups, or is this just 4 or 5 really smart guys that are doing this work?
Oh, no, it's really quite big here in New York City, at least, and I'm pretty sure it's big in London too, from the pictures I've seen. I mean, we get probably an average of 50, but when Dawn Signs came, we had over 100 attendees. So the groups are pretty well attended, and we're seeing a lot of people, especially in New York in finance, using it at their companies.
So finance, you mentioned finance. This gets to what we were talking about before, is that, very terse, very clear, very crisp, but very functional type problems. I keep hearing more and more about entire libraries being written in F# to support finance, and then having C# call those libraries.
Oh, definitely. And yeah, you build your UI in C#, and then you put your complicated finance logic in the back, and it's easy to read. It's easy to have a domain expert validate. It's a big win for everybody involved.
Philip, what kind of books do you, or websites, is there like a try F#, the way we think of like try Ruby? Like if a listener is gonna, get to work on their commute now and take 15, 20 minutes and learn about, F#, what would they do? How would they spend that 15, 20 minutes?
Absolutely. There's, tryfsharp.org. Yeah.
Oh, that exists. You're kidding. I just guessed. So tryfsharp.org. I'm going to do that right now.
Yeah, and you can, if you've got Silverlight, you can actually run F# in the browser. So if you're on Mac or PC, you don't even need to install Visual Studio. You can just go ahead and write some code. And it's beyond that. You can actually do graphical. You can implement graphics in the browser. So I've actually got a couple of games that you can run as snippets that you can just load in there and play with. So there's a missile command example. I've got like Tetris that runs in the browser, and you can just go in and edit and tweak the variables. So you have quite a lot of fun there. There's a website for snippets called fssnip.net, and basically there's hundreds of snippets being put up there by the community, just like short examples of pieces of code that you might find interesting, little games, all sorts really.
That's very interesting. The idea of a snippet website, typically I know in C#, if you find code online, it's probably garbage, and you certainly don't want to be copy pasting it into your stuff. But in a world that is more functional and immutable, it seems like a snippet would make a lot more sense. Like, is a snippet, Richard, much more useful in F# than it is in C#?
Definitely, and I would say that because F# is so young and the early adopter crowd has written most of this stuff, it's all pretty workable. Now, that's not to say there's not probably 10 different examples of permuting a list on there, but you just pick the one that is most understandable, or you performance test them using the timing function and the F# interactive, and you can do pretty well that way. Definitely, it's not hard, and it's pretty cool. The best thing about FSNip by far is Kamas actually made this thing that partially compiles the snippet and actually gives you the types with mouse over in the browser, which is wicked cool.
Wow.
Yeah.
Okay. So, Philip, if I was going to introduce F# into my organization, but maybe the bosses or the CTOs are going to say, I don't know, this is some obscure research language. This is built into Visual Studio though now, right? So someone could do this.
That's right.
Without fear that it's going to go away later.
Absolutely. We've had F# in Visual Studio. There was a plugin for Visual Studio 2005. And you can see it in the Visual Studio 11 beta now, so it's not going anywhere. But in a bad way, it's going everywhere. In a good way, we've got F# 3 coming out in the beta with a really exciting type providers feature.
So yeah, well, tell me a little bit very briefly in the end here about F# 3. Like, where's F# heading, and what kind of? I know that like a lot of async things have happened in C#. What improvements are being made to F#?
So the real big ticket item is type providers, and type providers is putting into the language the ability to connect to big data, to connect to web services, to databases, to Excel, to XAML, to DSLs, just through IntelliSense by pressing dot. So the example I kind of think of, let's say we wanted to do a mashup, and we've got some values in Excel. We want to pull some data down from the World Bank. We've got some data on a database. We can do that through type providers. We can pull that all in, and that will give us typed data through press dot. We can look over the types, we can look at the database tables, the fields, and we can join all of those together in one syntax. We won't have to code gen or anything like that. And seconds, minutes later, we can have that value, we can have that matched up. So hugely, hugely valuable in that area, the data mining.
Interesting. And that's all in .NET 4.5, or what do we call that? F# 3.
F#,
Yep.
yeah.
F# 3, and that's included with Visual Studio 11.
Absolutely, yeah. Very exciting feature. If you should check out some of the videos online. Thomas Petrczak was talking about it recently at QCon and a conference in London last week. Don's been out for a year now talking about it. Amazing demos. And you can do that mashup, you can do that data access from F# and then access that really easily from C#. So you can get those final values and push that into your business application.
And just to make it clear, in case it wasn't clear to the folks who've been listening this whole time, it's just all IL. I can go and add reference, and I can pick an F# library and call those methods. And as long as I'm using things within the .NET base class library that are shared amongst all .NET languages, I can move data in and out, no problem, between F# and C#.
Absolutely.
Yep, it's all IL.
It's all IL. I like that. Well, thank you so much, Phillip Trelford and Richard Minerich. I really take all the different links that we talked about, as well as other ones that Richard and Phillip think are useful, and we'll put them in the show notes, including the one that I'm checking out right now. Try F#. Appreciate your time. Thank you, gentlemen.
Thank you.
Thanks very much.
This has been another episode of Hansel Minutes, and we'll see you again next week.